Hello, I'm Yasilam Saddaq. In this video, I'm going to be leading you around a risk analysis technique or the core fundamental element of the FMEA.
I haven't failed. I have found 10,000 ways that don't work. Thomas Edison once said, I haven't failed, I have just found 10,000 ways that won't work. He understood that there is value in learning from failure. And lucky for us, over the many years since he made that observation, FMEA was developed to help us learn from failures before they even happen.
Similar of the quote of Thomas Edison, the FMEA is discovered the primary way a product or process can fail and take positive actions to prevent the failures before they occur. Let's define now what is an FMEA.
FMEA is a step-by-step approach for identifying all the possible failures in a design, in a manufacturing or in assembly process or product or service, studying the consequences or effects of those failures and eliminating or reducing failures starting with the highest priority one.
An FMEA want to help you and guide you into start putting your energy. Doesn't mean you will not work on the other places. That means that is probably the good place to start.
FMEA is a systematic process that requires truthful consideration for all the possible failure modes associated with new design or process, while you are developing the process to identify weaknesses. FMEA is one of the widely used systematic methods of quality risk management, which allow the process owner to anticipate the failure so that owner can prevent and address those failures before their occurrence. Let's move now to discover the two principal kinds of FMEA. The two broad classifications of FMEA methodology are DFMEA and PFMEA. DFMEA or Design FMEA is used to analyze product designs before they are released to production. DFMEA focuses on potential failure modes associated with the functions of products and caused by the design deficiencies. Hence, DFMEA aids in the design process by identifying known and foreseeable failure mode and then ranking failure according to related impact on the product. Second type, PFMEA or Process FMEA, comes after the DFMEA and is focused on analyzing your manufacturing or assembly process to identify all potential failure mode and then subsequently assess the risk associated with those process deviations. Process FMEA identify potential process failure mode by ranking failures and helping to establish priorities according to their relative impact on the internal and external customer. History of FMEA. FMEA was developed by the American military at the end of the 1940s. They developed this methodology that would eliminate all the potential root causes of munitions malfunctioning. A detailed method was developed, MIL-P 1629. After that, in 1960, this method was adopted by the nuclear and aerospace industry. NASA credited the success of the moon landing to its use. NASA was also concerned about contaminated food on space missions, that they developed a very similar technique called HACCP, hazard analysis and critical control points, specifically for the food industry. In the 1970s, slow speed chants involving the Ford Pinto were resulting in fatal fires if the petrol tank split. As we can imagine, this was a public relations disaster. To eliminate a reoccurrence for this and other serious problems, the Ford Motor Company implemented FMEA in their design process. In 1993, the AIAG Automotive Industry Action Group was using FMEA as a risk analysis tool and incorporated it into the QS 9000 standard for automotive production and its suppliers. QS 9000 became TS 16949, and since November 2016, IATF 16949. While FMEA was specifically aimed at automotive, other industries which demand the highest levels of reliability, for example, semiconductor, oil, and gas, have implemented it. These reliability standards are now extending to white goods and everyday electronic products. Purpose of FMEA. The main FMEA objective is the identification of ways in which a product, process, or service fail to meet customer requirements, as well as the ranking and prioritization of the relative risks associated with specified failures. Evaluation of the adequacy of corrective actions proposed to improve product, process, or service, and the prioritization of these actions can be supported by implementing the procedure proposed, which is based on the evaluation of corrective action feasibility. Let's move now to see when we need to apply the FMEA. There are several cases when you should apply an FMEA analysis, including when product is having its design updated or is getting a new design, includes new products altogether. A service is being transformed with additional new or modified steps. When a process or supply chain is being altered, changed, and modified. When you are developing new or updated control plans. Also, when analyzing failures of an existing process, product, or service. It's also good practice to periodically conduct an FMEA analysis throughout the life of a service, product, or process to ensure everything continues to run smoothly. Also, when improvement goals are planned for an existing process, product, or service. Why it's required to perform failure mode and effect analysis. Historically, the sooner a failure is discovered, the less it will cost. If a failure is discovered late in product development or launch, the impact is exponentially more devastating. FMEA is one of many tools used to discover failure at its earliest possible point in product or process design. Discovering a failure early in product development using FMEA provides the benefit of identify and prevent safety hazards, minimize loss of product performance or performance degradation. Also, we benefit to increase probability of detection, improve process control plans in the case of process FMEA, and improve design for manufacturing and assembly for design FMEA. Also, we benefit to reduce probability of failure occurring, prevention rather than cure. Also, collaboration between design of the product and the process, and finally, develop preventive maintenance plans for equipment. Let's move now to discover the process step by step for building an FMEA. The first step, assemble a team. An FMEA is an engineering analysis done by a cross-functional team of subject matter experts that thoroughly analyzes product design or manufacturing process. Early in the product development process, its objective is finding and correcting weaknesses before the product gets into the hands of the customer. Build a team composed of members who are very familiar with the aspects of business that will be worked on. The FMEA team members are ideally from different functions and can work together with the goal of identifying issues that need to be addressed. Second step, define your system or process to be analyzed. It's necessary to know and understand the product or process treated to define the scope of your study and be able to analyze it. Starting with a clear description of the process ensures that everyone on the team understands what is being analyzed. This step is essential to start an FMEA. By having little knowledge of the subject, you risk going off target and the results may be erroneous. Regarding the FMEA, a system block diagram can be used to show the interfaces and the relationship between aspects of your design. As illustrated, a system block diagram is a high-level modularization of the system that separates the overall system into maximally decoupled subsystems. System block diagrams enable one to visualize the system as large interacting components that can be conceptualized and developed independently. For process FMEA, you can use process flow diagram to define your process and its various manufacturing steps that can contribute to a failure. A process flow diagram helps you to understand your current process flow and visualize areas with potential risks, which makes it easy to collaborate with your team members and make sure you haven't missed any components. Once the team members agree that the process is clearly and accurately described, so they can move to next step. Now, let's talk about the potential failure modes. So, what is a failure mode? Failure mode is the mode, method, or way in which something might fail to perform its intended function. For the FMEA, it's recommended to start with a design drawing to identify features that, if they were out of specification, would impact the functionality of the product. For PFMEA failure mode will be related to various steps in the manufacturing process and how they might fail. So once you have listed all the potential failure modes, go through each one and identify all the consequences on the system, process, customer, or organization. In other words, for each failure mode, we need to ask the following. What happens when this function fails? How does a failure here affect the customer? So, what is the potential effect of failure mode? Effect is the impact on the end user or customer is refers to studying the consequences of those failure. Failure effect is a description of the impact of the failure mode on the operation function or status of the system. As illustrated in the picture below, each failure mode results in effects, and this failure mode has been already caused by a root cause. Generally, an FMEA analysis has three criteria for analyzing a problem. First criteria, the severity of the impact. Second criteria, the likelihood of occurrence. And finally, the probability of this issue will be detected beforehand. The next step is assign severity ranking. Severity is a measure of the degree to which the end user is impacted by the potential failure mode being analyzed. It assesses the impact of the failure mode, with 1 representing the least safety concern and 10 representing the most dangerous safety concern. In most cases, processes with severity scores exceeding 8 may require a fault tree analysis, which estimates the probability of the failure mode by breaking it down into further sub-elements. Next step is to identify the root cause of the potential failure mode. So failure cause is the how or why that leads to the failure mode. One of the best way that we can use to identify the root cause is the why analysis and fishbone diagram. Regarding the 5 whys process is used to dig into successfully deeper layers of the problem. So you need to ask why until you get to the root of the problem. Also, we can use Ishikawa diagram, also known as a cause-effect diagram or fishbone diagram or root cause analysis diagram. It helps to visualize a problem and categorize its root causes. Let's now assign occurrence ranking. The occurrence ranking is defined as the likelihood or probability that failure will occur. It assesses the chance of a failure happening with 1 representing the lowest occurrence and 10 representing the highest occurrence. For example, a score of 1 may be assigned to a failure that happens once in every 5 years, while a score of 10 may be assigned to a failure that occur more frequently, such as once per hour or once per minute. The next step is determine the current control. So a control is anything in your process that might prevent or detect the failure mode that is being analyzed. The current controls used to prevent or detect failures, and they can be tests, procedure, or mechanisms that ensure that failures don't reach the customer. These controls can prevent a failure from occurring or reduce its likelihood. They can also detect failures after the cause has been detected, but before the customer is affected. Let's now assign detection ranking. Your detection is a reflection of the capability and effectiveness of your process control strategy to identify failure mode once it has occurred. Detection, it assesses the chance of a failure being detected, with 1 representing the highest chance of detection and 10 representing the lowest chance of detection. The next step is calculate the risk priority number. So, what is the risk priority number? The risk priority number is the product of severity, occurrence, and detection ranking. The RPN give us a prioritization tool to determine the high risk failure modes that we should focus on. By multiplying the scores that you put in each one of those, you get the risk priority number, which helps you identify which area you need to focus on in order to begin your work for improvement. So this table assemble and describe step by step each phase in order to build the FMEA process. Once the analysis has been completed and the risk priority number calculated, corrective action or recommended actions are assigned to each failure mode. The severity, occurrence, and detection scores are then applied again to establish the new risk priority number once the action have been applied. No FMEA should be done without a recommended action list to improve the system design. Recommended action are taken to reduce occurrence and detection, in essence, to eliminate failures and thereby eliminate the system deficiencies. So this is the last and probably the most important step in the whole FMEA process. So taking action means reducing the risk priority number. The action plan outlines what steps are needed to implement the solution, who will do them, and when they will be completed. With your failure modes mapped out and ranked, you can quickly assess which areas of the process need corrective measures and recommended actions. This might mean making changes to the process or product design or adjusting the measures and controls in place to mitigate risk and detection. Your specific action plan should focus on the following objectives. First objective, eliminating failure modes from the process altogether where possible, minimizing the severity and reducing the occurrence of failure modes, and also improving detection of failure modes. How risk priority number can be reduced? For reducing severity ranking, only design of product or process change can reduce the severity ranking. Regarding the occurrence ranking, can be done by improving preventive controls like mistake proofing, revised instruction, validation and revalidation of process through DOE, and also reduced variation in process parameters. And also to reduce the detection ranking, it can be done by improving detection controls like SPC implementation, revised test plans including sampling frequency, and automated online detection. After implementing these actions, we need to note the results and recalculate the risk priority number to assess the progress and the impact. So during the re-ranking of the risk priority number, we need to confirm the relative improvement. The ranking severity never change. Occurrence can be changed and also detection can be changed. Well, after finalizing the FMEA, what should we do with the results? The last step is the most important one because if it's not done correctly, none of the previous step will benefit your product or process. So we use the result normally to mitigate high risk failure, to reduce severity of effects and probability of occurrence, implement controls to improve failure detection, create an action plan with schedules, and identify the people responsible for implementing each improvements. Reassess, create an action plan with schedules, and identify the people responsible for implementing each improvement. Reassess to ensure the objectives have been attained. The FMEA results help to improve the reliability of the service provided and ensure greater satisfaction among customers, users, and end consumers.
Remember, the sooner a failure is discovered, the less it will cost. Thanks for watching. If you enjoyed this video, please press like button and click on the link to subscribe to my channel.